Hi, we're here chapter 2.6. We are graphing rational functions. And you can see that this is example 1 where we have f of x is equal to 1 over x plus 1 minus 2. And you'll notice that this is in the format of y equals a x minus h plus k. And that way we have our vertex of the, or center where the two asymptotes meet, given to us there, and I'll show you that now. So, we're given this function, and the first thing we want to do in any of these cases is find the vertical asymptote. So step 1, find the vertical asymptote. How do we do that? We set the denominator equal to 0, so we get x plus 1 equals 0. We have a vertical asymptote at x equal negative 1. So I've gone ahead and drawn that in here on our graph. Vertical asymptote at x equal negative 1, straight down. And now we're ready to find the horizontal asymptote. So if we step over this way, now we can find the horizontal asymptote. Now there's a couple different ways. If it is in the format, or the vertex form, a over x minus h plus k, then it will be the k value is what we're looking for that horizontal asymptote. So since we had the function 1 over x plus h minus 2, we can conclude that in this case we have a horizontal asymptote at y equal negative 2. In other cases you might see that there's a polynomial involved, and there are 3 rules to follow in the polynomial situation. And that is, if we're here, we have y equals a to the x, a times x to some nth power in the numerator, and then in the denominator we have b times x to some nth power. And then those go through these rules, which my next video will show another example of that. In essence, though, when n is greater than m, there is no horizontal asymptote. You would in fact get a slant asymptote. If n is equal to m, then the horizontal asymptote is the ratio of the coefficients of a over b. Or if n is less than m, or the power of the numerator is less than the power of the denominator, then we get a horizontal asymptote at y equals 0. However, for this example, we do have a situation where we have y equals some a value over x minus h plus k. So I went ahead and drew the value there of our horizontal asymptote at y equal 2. So now we just need to plot some points. And let's get this centered here for us. And I can simply make an xy chart. And I can do that by x and a y. And if I plug in a 0, I'm looking to find a value to the right of the vertical asymptote, and then a couple values to the right, and then a couple values to the left of the vertical asymptote. So I went ahead and chose 0. And if you plug 0 back into the function of 1 over x plus 1, you get, if 0 is x, then you get 1 over 1 minus 2, which in that case would be at negative 1. So it's 0, negative 1. And if I chose to go to the right a little bit more at 2, we would get 1 plus 1 over 1 divided by 2 plus 1, which would be a third. 1/3 minus 2 is negative 1 1/3. So negative 1 1/3. Or negative 4/3 for those of you that like it in fraction form, okay, instead of the mixed number there. Then I can choose, and that will be at 2 negative 1 1/3, which would be there. And so we would see that this graph comes down in this sweeping manner like this and starts to hug the vertical asymptotes. All right, let's go to the left side now. And for the left side, I chose -2. If we plug -2 in there, we get 1 divided by -2 plus 1. I encourage you to write this down as I'm going through it. That would give us a -1. -1 minus 2 is -3. So we get -3. So -2, -3 is here. And if I go out a little bit further to -4, then what we'll notice is if I put -4 in the denominator for x, we'll get -1/3. -1/3 minus 2 will give us a value of -2 1/3. And so at -4, -2 1/3 would be right here about, approximately, and then this curve would come down this way and go that way. So you'll notice with these rational functions that they will have this type of action to them where the curves are in one or two of the quadrants. They're not always in opposite quadrants. You just have to plot some points. There are ways you can see if they're symmetrical or not, but for right now we'll just go with this, and hope you enjoyed that. Encourage you to rewind, watch this video, and study a little bit more. All right, thank you. Have a great day.